Assalamu alaikum, dear students. I am Ms. Sada Bahar, your physics teacher. I hope you all are fine. Nelson Mandela once said, "Education is the most powerful weapon which you can use to change the world." Well, dear students, to move ahead, in our today's presentation, I will explain Unit 10, Numerical Problems, from 10.5 to 10.10 of the exercise. The formula used here in solving the numerical problems are mentioned on the first page of the presentation. Dear students, to proceed towards the topic, first of all, learning objectives of the lesson. Learning objectives. At the end of the lesson, students should be able to solve numerical problems of the exercise, past papers, and any open related numerical problems by using the proper formula. Numerical problem 10.5. If 100 waves pass through a medium in 20 seconds, what is the frequency and time period of the waves? If its wavelength is 6 centimeters, calculate the wave speed. Given data, number of waves, 100, the time taken is 20 seconds, and wavelength of the wave is 6 centimeters, or 0.06 meter. Required data, we have to find 1. Frequency of the wave, 2. Time period, and 3. Wave speed. Solution: 1. Frequency. The formula for the frequency is F is equal to N divided by T. By putting the values in the formula, we get F is equal to 100 divided by 20 seconds, or F is equal to 5 Hz. 2. Time period. Formula here is as time period is equal to 1 divided by frequency. By putting the values in the formula, we get time period is equal to 1 divided by 5 Hz, or time period is equal to 0.2 seconds. 3. Wave speed. Formula: V is equal to F lambda. By putting the values, we get V is equal to 5 heters into 0.06 meter, or V is equal to 0.3 meter per seconds. Numerical problem 10.6. A wooden bar, vibrating into the water surface in a ripple tank, has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. What is the speed of the wave? Given data, frequency of the vibrator is 12 Hz, and wavelength of the wave is 3 centimeters, or 0.03 meter. Required data, we have to find here speed of the wave. Solution: formula for the speed of the wave is V is equal to F lambda. By putting the values in the above formula, we get V is equal to 12 Hz into 0.03 meter, or V is equal to 0.36 meter per second. Numerical problem 10.7. Given data, frequency is 190 Hz, length of the spring is 90 meters, and time taken is half a seconds. Required data, we have to find A. Period of the wave, B. Speed of the wave, C. Wavelength of the wave. Solution: A. Time period. Formula: time period is equal to 1 divided by frequency. By putting the values, we get time period is equal to 1 divided by 190 Hz, or time period is equal to 0.01 seconds. B. Wave speed. Formula: V is equal to S divided by T. By putting the values, we get V is equal to 90 meters divided by half a seconds, or V is equal to 180 meter per second. C. Wavelength. Formula: V is equal to F lambda, or lambda is equal to V divided by F. By putting the values, we get lambda is equal to 180 meter per second divided by 190 Hz, or lambda is equal to 0.95 meters. Numerical problem, 10.8. Water waves, in a shallow dish are 6.0 centimeters long. At one point, the water moves, up and down, at a rate of 4.8 oscillations per second. A. What is the speed of the water waves? B. What is the period of the water waves? Given data, wavelength is 6 centimeters, or 0.06 meters, frequency is 4.8 Hz. Required data, we have to find A. Speed of the water waves, B. Time period of the water waves. Solution: A. Speed of the water waves. Formula: V is equal to F lambda. By putting the values in the formula, we get V is equal to 4.8 Hz into 0.06 meter, or V is equal to 0.29 meter per second. B. Time period. Formula: time period is equal to 1 divided by frequency. By putting the values in the formula, we get time period is equal to 1 divided by 4.8 Hz, or time period is equal to 0.21 seconds. Numerical problem, 10.9. At one end of a ripple tank, 80 centimeters across, a 5 Hz vibrator produces waves, whose wavelength is 40 mm. Find the time the waves need to cross the tank. Given data, length of the ripple tank is 80 centimeters, or 0.8 meter. Frequency of the vibrator is 5 Hz, and wavelength of the wave is 40 mm, or 0.04 meter. Required data, we have to find first speed of the waves and then find time taken by the waves. Solution: speed of the waves. Formula: V is equal to F lambda. By putting the values in the formula, we get V is equal to 5 Hz into 0.04 meter, or V is equal to 0.2 meter per second. Now to find the time taken by the waves, we will use the formula: V is equal to S divided by T, or T is equal to S divided by V. By putting the values in the formula, we get T is equal to 0.8 meter divided by 0.2 meter per second, or T is equal to 4 seconds. Numerical problem, 10.10. Given data, frequency of the radio waves is 90 MHz, or 90 into 10 power 6 Hz. Speed of the radio waves is 3 into 10 power 8 meter per second. Required data, we have to find the wavelength of the radio waves. Solution: formula: V is equal to F lambda, or lambda is equal to V divided by F. By putting the values in the formula, we get lambda is equal to 3 into 10 power 8 meter per second, divided by 90 into 10 power 6 Hz, or lambda is equal to 3.333 meters. Dear students, I hope you all understood Unit 10 well, and I hope too you are now able to attempt any type of related question in the exams. Well dear, at the end, I would say for you, you are somebody who wants to make a difference. You are somebody who wants to make our tomorrow better. I want to challenge you today, that to be the first, because people will follow you. Be bold, stand up, be fearless, and be confident. Thanks.